Hello and welcome to Edinburgh Skeptics on the Fringe. We're here tonight bringing you a talk on the epistemic nightmare of engaging with climate trolls, which we thought was timely given the IPCC report that came out this week. We have had to have a radical change of plan. We were expecting to have someone from the Ferret, which is an investigative journalism collective working in Scotland, and they're doing great work, and I suggest that you follow them. Unfortunately, they had a family emergency and they couldn't make the talk, but I do think they're a great organisation and we should support the work that they do. But thankfully, one of our friends over at Glasgow Skeptics was able to step in and bring us this talk. He's been working as an ecological modeller at the University of Strathclyde, and hopefully, as of tomorrow, if he passes his Viva, will be the newly announced Dr. Trevor Sloughter. So he's going to be helping us out this week. We're still nailing down who we're going to have for our talk next week, but follow us on Twitter, Facebook for updates on that. And apologies if you happen to get 71 invites to tonight's talk. We had a bit of a fight with Facebook and it won't happen again, we promise. If you've got any questions that you want to give to Trevor for us to pop to him at the end, you can either pop them in the chat underneath us in YouTube, or you can send them via Twitter or Facebook, or even via email. We've got someone monitoring every income. So send us your questions and we'll put them to Trevor at the end. Also, if you want to check out some of our back catalogue, we've got a podcast which has various talks and interviews going back over the last 5 or 6 years, and also our YouTube where we've had talks online for the last couple of years for obvious reasons. But tonight I'm going to give you the nearly Dr. Trevor Sloughter and the epistemic nightmare of engaging with climate trolls. Thank you very much.
Right. Well, thank you very much for that introduction, Heather. And thank you, everybody who's watching, for coming along. I can't actually see how many of you are there, but I assume it's a few. And even if it's just one, that's really fantastic. And I think that's great. As you can probably tell from the title of the talk, what I learned from the epistemological nightmare hellscape that is engaging with climate trolls, it's going to get a little weird tonight. To begin with, maybe I should probably clarify actually first that these little logos you see up on the title slide, I want to make absolutely clear, I'm not speaking officially on behalf of any of these groups. I'm not speaking officially on behalf of the University of Strathclyde. I'm not really even officially speaking on behalf of Glasgow Skeptics or the Climate Reality Project. They're more to just sort of give you an idea of where I'm coming from. So yes, I'm currently affiliated at the University of Strathclyde, where I do ecological modeling. I have done some volunteer outreach for the Climate Reality Project before, and I volunteer with Glasgow Skeptics. But this talk is purely coming from my own views, my own experiences, my own ideas, basically. I like to begin every talk that I give on climate change with a couple of references, some books that I think are good to learn from, to get started, basically introductions. The one on the far left, The Discovery of Global Warming, that's a history book. The author is a historian and a physicist, and the book, it's quite short, and it is a summary of the past 150, 200 years of study of climate change and how that science was put together and developed over time. And it's also been adapted into a website that you can view for free. So all the contents are free online and they're up to date as of this year. Really recommend checking it out. The two books on the right, those are technically textbooks for undergraduates, but I think that there's a considerable amount of material in both of them that is accessible for anyone at any level if you really want to learn more about global warming and climate change as a science. So I recommend these. Now, to begin the talk, I want to start with a thought experiment. We are going to do a little hypothetical. I am going to make a prediction, and I want all of you to let me know, or, well, I can't actually see the chat window, but let our lovely moderators know by typing into the chat how much you're willing to bet on the prediction coming true. If you think it's not going to come true, then you can say 0. But you are welcome to bet any amount of money you want. £0, 50p, 500, whatever you like. the prediction is this. On October the 23rd of 2034, at exactly 5:07 p.m., in the city of Glasgow, it will be raining. How much money are you willing to put down on that? 0? 500? 50? 5? Now, many of you may be thinking, well, Glasgow is a fairly rainy place already, especially in October, so putting a little bit down, I won't lose much, but, I might get something back too. But let me ask you something different. Let's say if I change that prediction, and I instead ask you to bet on the prediction that for the entirety of the years 2030 through 2040, the entire island of Great Britain will receive a total amount of rainfall greater than the rainfall for the Sahara for the same time period. Now, how much money are you willing to put down on that prediction coming true? Now, again, I can't actually see what you're responding, and I bet a lot of you are shy and not really responding at all. And quite possibly some of you are watching this recorded, and if you're trying to talk to me, that's even worse. But let me just sort of hazard a guess here that many of you thought, well, the latter example is much more likely to be true, all things considered, whereas the first example is much more unpredictable. The interesting thing is that regardless of what you answered for either question, you made climate models in your head and you extrapolated them into the future. You made a prediction and you assigned a probability to it. Even if your answer to both of those predictions was climate is too unpredictable to know, and you said £0 both times, that in and of itself is a climate model. You have modeled the climate in your head as unpredictable. You've made a prediction about where it will be in those time periods in the future, and you've assigned a very broad probability distribution to possible results. And if you're thinking, well, these two different predictions are on such extreme ends of the spectrum, one is so highly specific and one is so broad, that it's really common sense which one is more likely and which one is the better bet. Well, then I want you to stop for a moment and really think about what makes something common sense. Where are your assumptions coming from? Where have you gotten your information? How confident are you in it? How often do you stop and interrogate it? And, how much have you really thought this through? Can you really defend it if it comes up against scrutiny? If a small child comes up and does that thing small children do, where they keep asking questions, why, how far will you be able to go in defending this? These are questions we don't always think to ourselves. We often offload responsibility for large scientific questions onto, well, professional scientists who are working in it, right? So I just want you to bear those thoughts, those ideas, those questions, just let them sit in the back of your head while we go through the rest of this talk, because the underlying themes we're going to explore here are relevant to how we approach questions like that and how exactly we deal with our own scientific literacy. And we're going to unpack this through the lens of trolls. So we probably need a working definition of what a troll actually is, don't we? Well, for the sake of this talk, and I know that there can be some debate and some nuance here, but for the sake of this talk, we are going to say that a troll is someone who intentionally seeks to disrupt a conversation or inflame tensions without concern for any other parties in the discussion or for the outcome or result of the discourse. A troll may or may not believe what they say. That's not the important point. The point is that trolling is a behavior. It is a tactic to shut down a discussion, and it can even be unintentional. Some of the people we will see today may have actually believed what they were trying to advocate for, but got carried away in the moment and turned into trolls, shutting down what could have been a good discourse through that negative behavior. To be clear, though, simply disagreeing with the consensus or asking questions or being skeptical doesn't necessarily make one a troll. In fact, even if you're a huge dick and you're saying really rude words and being really mean, you're not necessarily a troll. Sometimes that just happens in a discussion, especially if you're passionate about it. Up here, we have a couple of examples. We're not going to unpack them in much detail, but if you can see them, you can probably see that, well, this is Edinburgh Skeptics. We're a skeptics community. There's certain buzzwords in a couple of these comments that might raise a red flag for us as skeptics. Phrases like fake news, do your own research, it's just a theory. We've heard those before, and they very frequently come from trolls. All of these people making these comments, though, were willing to actually engage in a meaningful discourse, and they did genuinely care about both their own beliefs, interrogating themselves, as well as trying to convince others in a real way. So even though some of them ended up saying things that were very, very wrong, I wouldn't classify them as trolls. Contrast this with this person who he posts a quote from the first assessment report of the IPCC published in 1990. And this quote that he has copied and pasted from that document says that the best estimate, and remember, not the only estimate, the best estimate, is that between 1990 and 2030, there will be a sea level rise of anywhere between 8 and 29 centimeters. He goes on to call this false science because, quote, are we 7 or 11 inches deeper in water? No. But how much has sea level risen between 1990 and 2020? More than 8 centimeters. That's more than the lower bound that was given for the year 2030. So we've already hit that target. It's just that it was a broad target. Yes, there was a best estimate in between the 8 and the 29 of 18, and we're not there yet, but we're in the range, as was very explicitly stated. And no matter how many times it was pointed out to this person that they literally said that in their own comment, they refused to let go. And in fact, many times said to me explicitly, why do you keep bringing up 8 centimeters? I don't know if you can see my cursor, but it's right there. He even converts it into inches. It's mind-numbing. It's mind-numbing. And this is what I'm talking about when I say that there are people that don't really care. They're not interested in convincing or sharing information. They're interested in stopping discussion. Let me give you another example. These are 2 separate accounts on the left and the right. In the dark blue, well, since they're anonymous, I'm going to need to use a pseudonym. So let's call the dark blue Surf Ninja. Surf Ninja kept asking the exact same question over and over, no matter who answered, no matter how they answered. This person never acknowledged the answer. They never said, your answer is wrong, here's why. They never said, I don't believe that, here's why. They just asked the exact same question repeatedly. Some days later, the second account, the one on the right, was asking the same question with very similar wording. And I found that very interesting. More interesting, as I was engaging with the second account, I realized that Surf Ninja had gone oddly silent since the second account had turned up. And then I realized, well, one day, several weeks prior to second account showing up, Mr. Surf Ninja had posted an article about how Greenland used to have less ice and therefore used to have plants on it. And then several weeks later, after Surf Ninja had gone silent and second account had showed up, second account refers to that Greenland article and that comment in the first person. This, to me, was sort of the nail in the coffin because I was already a little suspicious, but I really should have figured out earlier that second account was a fake account because of the name. I'm now going to reveal to you that name, Alan Gore. Now, of course, in hindsight, yeah, Alan Gore was probably a fake account, but some people out there in the world probably have the name Alan Gore. So I wanted to be trusting, even though that name is like, and the profile photo is Borat. I waited quite a while before really realizing that this was a fake account. And for what it's worth, the only reason I've unanonymized it is because I know it's a fake account, because Facebook knew it was a fake account and took it down after a while. And then Surf Ninja showed up again. And then Surf Ninja went away and a different account that sounded exactly like Surf Ninja showed up. And I'm not actually sure how many accounts are connected with Mr. Surf Ninja. I don't even know if Surf Ninja was the original account of this person or not. But this is what we are dealing with. And to that end, here's the outline of the rest of the talk. Now, just to be clear, this is a very front-loaded talk. Almost the entirety of the time is going to be devoted to section 1, and then sections 2, 3, 4, we're going to speed through in the last like 5 minutes. The reason I'm doing this is complicated, and hopefully it will become clear throughout the talk. But basically, I wanted to structure the outline in a way that reflects the categories of trolls. And I've broken them down into 3. And again, it's up for debate, but this is how I like to approach it. You have trolls of the first type that are science deniers. They are there to deny climate change is happening, or that it's going to be bad, or something about the science of climatology. That's what they are there to deny. Section 1 is going to be about how this works sort of epistemologically, sort of like our theories of knowledge. How do we engage with science? How can we be scientifically literate? That will give us a common ground, a baseline from which we can then approach in section 2 some specific examples of how they deny climate. And we're not going to touch on nearly even half of all of the possible arguments. There's just so many, and I couldn't even pick my favorite ones, which is really sad, but maybe we can get to them in the Q&A. The third section will sort of go through fairly quickly, because once we've established how to think about their arguments and why they're doing it, we can really quickly just take a look at the reason that they're doing it, and that really comes through in the second kind of troll, the ones who are always saying that the solutions are wrong. So these are the ones that don't want to talk about the science, either because they've given up on that front or because they even accept it, but they don't like any of the ways of dealing with it. And that, I think, really highlights the motivations for the first kind of trolls, but we'll see that when we get to it. And I also want to state up front about section 4 that even though it's going to be really, really quick and happen at the very end of the talk, I do want to be clear right at the beginning, we are going to have to talk about eco-fascism, and we are going to have to talk, I know it'll be brief, but we do have to bring up acts of terrorism that have been committed in the name of eco-fascism. It'll be uncomfortable, but as I will explain when we get there, it's not something we can ignore if we actually want to talk about the full scope of climate trolling on social media. It's sad, it's unfortunate, but it is relevant. And that will come at the very end, so full warning. For now, let's just get ourselves a common groundwork that we can all share for becoming scientifically literate and dealing with the trolls of the first variety, the denial of science in whole or in part. These come in many different flavors, from the sort of very low-level philosophical, the entire concept of truth and evidence is wrong, therefore we cannot know anything, and so there's no point in discussing it. These aren't as common. That's such a radical position to take. It happens. I've encountered it more frequently with, say, young Earth creationists or flat earthers than climate truthers, but it happens. The next level up, I would argue, is the conspiratorial, the ones who say, yes, evidence-based reasoning is a good idea in principle, but we can't get the evidence because there is a conspiracy. The entire scientific community, all the tens of thousands of scientists, are manipulating the data so we don't know what it actually looks like. Taking a step up from that, there's the ones I call condescending, who say that, well, no, some of the science is actually right. Some of the evidence is perfectly well measured and accurate. The problem is scientists don't know how to interpret it. I do. All the tens of thousands of scientists, they got it wrong. I got it right. Then moving a little more narrowly, there's the specific kind who try to use one or two specific flaws that they find as a wedge issue. They'll accept most of the science, but then they'll pinpoint one thing and say, well, this is just one mistake, but it's the wedge that sort of breaks the whole science. And then the final variety is the kind that says that, either that the impacts of climate change are overblown, or that adaptation will be so easy that it's not worth worrying about. And this is a form of science denial as well. Now, I don't really want to dwell on the philosophical because one, they're so uncommon, and two, look at it. Look at the things that they say. Data is exactly that. Data, not evidence. Believe what you must. I don't want to deal with that. What do you do with somebody like that? More seriously, though, better people than me have already spoken for various skeptics groups about this. Oh, I don't remember his name, but look up the talks on street epistemology. You'll basically cover this in a much more comprehensive, better way than what I could do. And also, I'm drained. I'm not dealing with that. No, I want to start off with the more conspiratorial kind. You know the types, the ones that say that there's no debate because it's been stifled, that, quote, climate bullies never want the actual truth and science out there. The ones who say that we're never allowed to hear from experts on both sides. Yeah, you know, the types that say, well, where's the debate? It can't be scientific if there isn't a debate. So to that end, we probably need to talk about what science is. I have another question for you in the audience. What is the shape of the Earth? And how much debate on that do you think is reasonable? And while you argue with that in the comments, I'm going to take another drink of Iron Brew. Maybe that will get me a sponsorship. Oh, wait, no, then I'd be compromised and I would have a conflict of interest, wouldn't I? I'm not sure how Iron Brew would have a conflict of interest with ecological research, but actually, no, I can think of a lot of ways. Anyways, so hopefully you've had a robust discussion about what is the shape of the Earth and how much you think it's worth debating. Many of you are probably already aware of this, but there's an entire field of ongoing, active, lucrative research called geodesy. That's the scientific study of the geometric shape of the Earth, its orientation and movement in space, and its gravitational field. Because yes, on the very largest scales, Earth is basically an oblate spheroid. We can model it with an ellipsoid. But an ellipsoid is perfectly smooth, and look out your window, the Earth is not. The Earth's mass distribution is not perfectly uniform. It has variations in its gravitational field. Its orbit and rotation affects its own internal movements. The surface is moving, the interior is moving, which causes changes to the surface. It's got mountains, it's got trenches, it's got crevasses and canyons. So it's not really perfectly smooth, is it? We do need an actual accurate measurement on various different scales of the true shape of the Earth. It's relevant for map making, for navigation, for surveying. So there's actually quite a lot of ongoing research. And what that means is that there's actually quite a lot of ongoing debate. Because, well, what resolution do you need to go for a specific purpose? What instrumentation is the best for a specific resolution? There's going to be genuine discussion about this. You'll never see a paper in a geodesy journal arguing for flat Earth, not because debate is being closed, that's being shut out, but precisely the opposite. If you want to come in and make that argument, you have to come in with data and methods and analysis that holds up to the debate, to the scrutiny. That, in and of itself, is more of a realistic portrayal of what scientific debate actually looks like. Something hasn't been shut out because it's being top-down imposed as being bad, but a hypothesis has been shut out because it was tested, it was analyzed, it was studied 2,500 years ago. That part's done. We're focusing our resolution at a lower scale now. So now I want to ask you, what do you think of when you think of climate science? What is it? Well, I have bad news for you, but it looks like this. And this. And okay, I'll admit it, I'm being kind of cheeky. These equations are not in and of themselves particularly complicated. okay, the long one in the middle of the integral is not the simplest thing, no matter how you write it. But the two ones on top and even the one on the bottom, there are ways of writing those equations that are a little more friendly. They get longer, but when you really break apart what each of those, excuse me, when you break apart what each of those variables really stands for, it doesn't become all that hard. But the point I really want to make, and I'm doing it in a slightly cheeky way, but the point I really want to make is that climate science is like every other science. It is extremely mathematical. It is based in maths and physics and statistics, and that physics has been robustly tested in laboratory experiments for over 200 years. Yes, over 200 years. Climatology may be around 100 to 150 years old, but it's based on physics that goes back much further. And so when we think of the end result, the nice pictures of temperature profiles or precipitation patterns, those are the end product of an immense amount of very difficult calculations, measurements, physical theory. It's a lot of hard work that forms the sort of the under the hood that's going on in there. To be absolutely clear, you can absolutely have a very informed, critical perspective of these results without being an expert in all of that math. It's entirely possible to become knowledgeable enough to have a criticism without completely grappling with all of that math. That's certainly true. The problem occurs in whether you know that math even exists in the first place, or whether the entirety of your knowledge is the end result. There are three figures on the screen right now. They are all global average temperature anomalies from different institutions that have performed different analyses. Now, there's a lot of overlap in the data that they collated to make these, because I mean, there's a finite number of weather stations on the planet, and you want to get as many as you can. So yeah, there's a lot of overlap in what weather stations you're using, but it's not completely perfectly synonymous. And they are independent analyses using slightly different methods performed by different people. The one on the bottom right, that's the European ECMWF, one of those. The one on the top right, that is the UK's HADCRUT. And the one on the left, that comes from the Japan Meteorological Agency. When I've been talking to climate trolls, mostly on Facebook, I exclusively share the temperature data from the Japan Meteorological Agency. And the reason I do that is because these people have never looked under the hood. They've never really asked what's going on to get to the results and the conclusions that climate scientists have come to. They don't know Japan exists. And then I get responses like this, where I post the JMA data and they say, what's the source of that? Is it NOAA? And then they go off on their pre-established spiel about why NOAA is bad with no evidence to back it up. And that just speaks volumes to where climate trolls are really coming from. Not all of them. Don't get me wrong. Not all of them. But man, this happens so many times. Of just moments after this is that data from NOAA. This person says, it's funny you haven't mentioned any well-known climate scientists or their research. I posted the JMA. The JMA is one of the biggest, most seminal institutions. All right. Yeah. But what would have happened if he had actually clicked on that link? What would he have actually seen? Well, if you go to the JMA website, this is fun. They explain to you where the data comes from and how it's synthesized into a global average. Now, this page here, I just took a screenshot of it. It is a very, very short, condensed summary. There aren't any equations. There's not like, you can't click on those spots and see where they all come from. It's just sort of a summary of the steps that were taken. But you'll notice there's also references. And throughout that whole website, you can find the technical reports and references to peer-reviewed research that establish the methods for where they get their data and how they analyze it to create the global average. So it's like I was saying earlier, there's all this stuff under the hood. And if you really, really, really wanted to take down climate science, it's there for you. It's not being hidden. You are welcome to become an expert yourself and figure out how this works and start making real criticisms. But that's not what we get. And that's sort of kind of their point, that they're not actually targeting somebody like me who might actually know how it's done. They're just trying to disrupt the discourse at a wider public level where a lot of people might not know any of these details whatsoever. And what I want to convey is that it doesn't have to be that way. Because this stuff is so transparent, actually non-experts could start learning these things. There are a number of barriers, I admit that. But we should start thinking about ways of getting more people involved in that level of scientific literacy. So I mentioned that there are references that are cited on the JMA website. Well, where do you go and find them then? Because, okay, so there are links to them, but on the website, but maybe there aren't. Maybe they only give you the title and the author or something. What do you do then? Well, we live in a very wonderful age in terms of access to science, because now there's ways of searching for them with the internet, and there's so many search engines that exist for peer-reviewed scientific literature. And some of them are subscription-based, which is kind of annoying. Scopus and Web of Knowledge, they're pretty good, but yeah, they are subscription-based, and that's a barrier. But JSTOR's not. You can freely get into JSTOR. ResearchGate is a social network for scientists where they often post their own articles as PDFs, and they also will often post like summaries or details about them, and then you can go search for them elsewhere. ORCID is a database for searching for authors. So if you know that there is somebody out there you want to find the research of, ORCID's great. And then even Google Scholar. There's a lot of hesitation about this because Google is, well, Google. But Google Scholar has one of the widest databases for trawling peer-reviewed literature. It has its own problems. It doesn't do a great job vetting a lot of predatory journals. So it certainly got its own issues, but it also casts such a wide net, and it has so many useful little features that are great as a free-to-use service. If you find an article with Google Scholar, you can click on the authors and see their whole publication list, including conference presentations. You can also find out which articles are citing the article you're looking at. If you pull up an article on Google Scholar, there's a button you can click and it will say, here are all the articles that came after it that cite it. And so you can follow the development of the research further on. So there's all these great tools. Now, reading a scientific paper can be a little bit intimidating to non-experts, even other scientists. It's very intimidating if you're not an expert in a particular field, no matter how much science you know. And this is another thing that trolls will sort of try and prey upon. We think of the archetypal structure of a scientific paper as being your abstract, your short summary of the paper, followed by an introduction to give background. Then you describe the methods you undertook, you present the results, and you discuss them with nuance and put them in context, and then you're done. There are other ways of writing articles. This is sort of like the archetype, and it's a very useful structure, even if you don't necessarily title your sections like that. It's a very useful structure. It's important to understand the differences between those sections, however. Let's take a look at another troll. We haven't looked at a troll in a little bit, so we need to take a look at one. So there's a troll. Bear with me here, because this is wild. There was a troll who was very adamant that the Earth is currently cooling, all right, and that it's cooling because of an unprecedented rise in cloud formation. Okay. And that this cloud formation rise was caused by an increase in cosmic rays. Didn't provide any data for that. And that this increase in cosmic rays was the result of unprecedented low levels of solar activity. Okay, no evidence for that either. Yeah, the whole chain of logic doesn't really hold together, but at the core of it is this idea that cosmic rays, solar activity, and climate are this three-way dance that are well correlated and well established. So I sent this troll one paper, Cosmic Rays, Solar Activity, and the Climate by Sloan and Wolfendale. And it's just one paper. It's just a little meta-analysis that's looking at some time series of historical data on all three of those to basically show that, yeah, cosmic rays are influenced by solar activity. There's good reason for that. And yeah, maybe there's a little bit of relationship between cosmic rays and clouds, but there's really not a good way of linking all three of these. It doesn't show up in the data. So even if there's like a really weak connection there, it's certainly not strong enough to be causing global cooling right now. And what this person responded was that they stopped reading the paper at the sentence, "The presence of CO2 and water vapor makes the atmosphere a strong absorber of IR radiation." They said, "No, that sentence is wrong. I will read no further." Do you want to guess where in the paper that sentence shows up? It's on page 1. It's the third paragraph. Well, fourth paragraph if you count the abstract. It's in the first subsection of the first section. The thing is, this is an introduction section. For the sake of transparency and scientific integrity, when you're introducing your topic and providing your background, you're not supposed to be presenting your own opinions, your own new science. That comes in the results and the discussion. You can seed the idea that established science might be wrong in the introduction. You can say like, well, the current consensus is X, or many believe that Y, implying that you're about to show why this is actually not really true. And that happens all the time. Like, obviously your own opinions do filter into the introduction, but theoretically, you're just sort of summarizing what's already there to give a broad context to your paper. If somebody says something in the introduction that's wrong, that doesn't necessarily mean anything else in the paper is wrong. I mean, this isn't even related to what the paper is about. The paper is about cosmic rays, global temperature, and solar activity. It's not about what CO2 is doing. It's not about the thermodynamics of CO2 in the atmosphere. That's just relevant background to the broader discussion of climate change. The authors make no analysis of that. So the fact that he stopped reading there indicates that he doesn't really know how a scientific paper is structured and what it's trying to say. And something that is really, really common is that trolls definitely, but also, unfortunately, a lot of climate activists, people that are supposed to be on my side, make this mistake of opening up a paper, reading the introduction, and using that paper, something that is said in the introduction, as evidence of a conclusion. Introductions of papers can be used as evidence for, what science is out there, what scientists are thinking, because again, you're summarizing the literature, right? So it's not terrible, but it's not the actual point of the particular article. It's not the novel research. So yeah, bear that in mind whenever you're seeing somebody cite a paper. You should probably check which part of the paper they got that it from. Was it the discussion and the results? Was it the introduction? Very big difference. Now, suppose you want to go off and you actually want to find the data. Well, a couple of interesting things about that. In general, data are published. It needs to be out there so that other scientists can inspect it, so they can work with it. It's not just about verification, although that is very important. It's also just about other people being able to do more science. So the data are quite often just out there, whatever you want to find. If you find a scientific paper and it's talking about data you find interesting, somewhere either in that paper, in the PDF document, or on the website where the paper was published, it's going to say where they have the data stored. And then you can go get it. Okay, caveat emptor. So not all data is like a simple spreadsheet where it's just a list of numbers that you can easily scroll through, maybe make a line graph. Some data are really, really complicated. Some are really, really massive. So you may encounter that some data are only stored in file formats you've never heard of before, like netcdf. And then you have to go find a program for opening netcdf. And then that's not a visualizer. Then you actually have to figure out how to visualize it. So yes, there are barriers of entry, and I'm not saying that every person out there should go get the data and start analyzing it themselves. But I do think it is really interesting that data are out there and there are ways of getting into it. And you can go take a look at things. Do you want to look at the average CO2 for the global atmosphere? Sure, you can go find that. But you can also find it station by station. You can find specific ice cores and look just at that. Do you want to see the record of solar irradiance, the energy coming into the planet? You can find that. You can get spreadsheets. You can get spreadsheets of sunspot numbers. You can get documents on methane concentrations, and you can find the individual weather stations. It all is out there. The tricky thing is knowing what to search for in the first place. That's why reading papers to start off with helps, because that might cite data that you decide you want to look up. But on top of that, you really probably do need to go back and make sure that you've really learned a lot of the basics and the terminology that is applied here. That means reading textbooks like Global Warming, The Complete Briefing. That means going to institutional websites like NOAA's Global Monitoring Laboratory has so much on their websites explaining what everything means. What do all these words mean? What are they referring to? Why are they important? These days, what's really, really great is so many scientists have social media and their own personal blogs. In the lower right corner there, we have the blog of Jacqueline Gill. She's a paleoecologist. She's wonderful on Twitter, and she has this wonderful blog. And there's so many scientists like that. Kate Marvel and Catherine Hayhoe are climate scientists. Zeke Housefather is an energy analyst. He's written some great papers on climate modeling. They both maintain their own. They all maintain their own or contribute to somebody else's blogs, and they all do a great job of breaking down science in really accessible ways so that anybody can really pick up on the key words that they need to start really digging in a little deeper on their own terms. Maybe you'll find data sets that you've never thought of before and you find really interesting and you're fascinated by them. That's great. If you are not willing to do this, though, if you are like a troll who comes up with an opinion that the science is all wrong, therefore you refuse to even read the books. If you're like, well, the book is wrong, why should I read it? Well, because then you don't know what the book is saying. Then you don't know how to actually investigate whether it's wrong. Then you turn into this person. These are just two out of I don't know how many examples of this person repeatedly saying that all the extreme weather is being caused by northern hemispheric wobble. And they just kept saying it, and they wouldn't say what wobble means. They just kept saying wobble, wobble, wobble. If you've studied this at all, you probably know that wobble can refer to, the Earth's axial tilt with respect to its orbital plane, but it can also refer to the precession, sort of the movement around sort of like this sort of like rotational spin that this axis is going astronomically as it goes around the sun. But it can also refer to polar motion, which is a different thing from both of those. That's three very different things that can all be called wobble. And at one point, this person used the term wobble to refer to variations, cyclical variations in the way the moon orbits the Earth, which is very different from the first three wobbles. And this person conflated all of them. And I'm just so tired all the time now. Well, like I said, that was the bulk of the talk. We're going to speed through the rest. As we do, I want you to bear in mind something fairly important. These two questions are very different questions. There's a difference between how well does the evidence support a hypothesis as opposed to how well does a hypothesis explain the evidence. We often think, okay, given this evidence, how likely is the hypothesis to be true? But there's a flip side to that. You can also ask a question, let's assume the hypothesis is true. What are the odds that that hypothesis would produce the evidence as we see it? It's very easy to conflate these and mix them up. But think of it like this. It's very easy. We could say that our hypothesis for warming temperatures on the Earth is that there are alien spaceships that are invisible on the moon hitting the Earth with heat rays. Well, that would explain the evidence of a warming Earth. That must be a good hypothesis. The problem is the evidence doesn't actually support the hypothesis the other way around, does it? These aren't the same question, and they can have different answers, and they both need to be considered when you're doing hypothesis testing. You can't do one or the other, and you need to be very, very careful that you're not saying this is a good hypothesis because of what a great job it does explaining the evidence. It's the other way around might be your problem. So let's bear that in mind as we flip through a few examples and get to our finale. So it's speed round time. So do you remember that guy from a little while back in green? Well, I considered him my nemesis for several months. He may be a bot. I don't know. He liked to say that the Earth is cooling. Remember? He blamed cosmic rays. Now, why did he do that? Well, here's an interesting thing. So first of all, the Earth is warming. I don't know where he's getting his information from, except I do, don't I? He's cherry picking information. Why is he cherry picking information? Well, here's a fascinating thing. If you copy and paste the text that he's been commenting into Google search, you'll find that he has been copying and pasting from a blog called Electroverse. In fact, exactly the same text, and has been taking the images. He never cites this blog. He never acknowledges that that's where he's getting it from, or he did eventually when I called him out one too many times. Whew. What is this blog? What is Electroverse? Well, Electroverse is one of those websites that finds every single incidence of cold that's happening on the planet and says, haha, this is proof of global cooling, and ignores every single incidence of heat records. Another interesting thing about Electroverse is the very weird name. That is a weird name, isn't it? Why Electroverse? Have you ever heard of electric universe theory? That's the conspiracy theory that gravity, as well as the strong and weak nuclear forces, do not exist, and there's a conspiracy to suppress this information. Electroverse will frequently make reference to the idea that the universe is electric. Well, it used to. Lately, it's been purging itself of that. Take a look at this article. It tweets out with a quote from it talking about the electric universe model, but the actual article no longer has that quote. But if you Google it, you can find the cached article. It does have that quote. Somebody realized that they were looking very silly, but the problem is they keep doing this to the present day, talking about electric universe and then editing the article. Very suspicious. This is why citations are really important. You really do need to explain where you're getting your information from. Take this person, Dave White. He, quote unquote, published a paper in a journal which claims to, cause problems for the consensus on climate change. One of the lines in that paper is, quote, the data for graph 2 came from a scholar in South America. Let's ignore all the problems with the graph and just go to the citation he provides for this data. Oh, it literally just says some guy. And then it provides a URL to an article that provides none of this data. Wonderful. What about people who say it's actually the sun? Well, did you know we actually have data for the sun? We can see it going up and down during the same time period that temperatures have only gone up. We can also see that the variation has been within a very narrow window, as opposed to the large amount of energy imbalance that the Earth has been experiencing. Ergo, it can't be the sun. But on top of that, the troposphere, the lowest part of the atmosphere, is warming, but the stratosphere, the higher up, much thinner part of the atmosphere, is cooling. If the sun were warming the troposphere by getting hotter itself, that would also be putting more energy in the stratosphere. It would be warming. If the sun is causing the stratosphere to cool because it is cooling, then the stratosphere should be cooling. The fact that both of them are doing different things kind of puts the whole problem for the sun idea. In fact, this was very nicely summarized in an article. I won't read the whole quote, but if you want to go back during the recording and take a look at this citation, I love this article. It's great. Give it a read. It's not the sun. What about CO2? I'm not going to get too much into this, but I just want to get you all sort of thinking, how well do you fully understand the greenhouse effect? Because it's actually very complicated. And sometimes trolls will notice that it is very complicated, and the simplistic greenhouse summary is not the perfect metaphor, and they'll harp on this and get people to doubt, because a lot of people don't know the full details. And if they can hit that little arrow of doubt, that is a problem. But the fact is, we do understand it very well. The fact is, we can directly assign attribution to humans, and there is so much data out there about this that is accessible that it makes me very sad that this argument continues to happen. We're going to skip over this because I am so incredibly tired of talking about this one, but I have bad news for you. back in the 1970s, we were not saying that global cooling was about to happen. The vast majority of scientists were saying, we don't actually know. We don't actually know. Throughout the 70s. Sorry, that's just the way it was. The second type of trolls, these are the ones that just want to interrupt solutions. Like I said, this is the ball game. This is what they're really about. They'll play the blame game, say it's actually all China. You're going to ruin American business. They'll try and change perspective and say that it's actually livestock, not fossil fuel burning, even though, well, that's very not true. And even though, well, China's quite a lot, but so is everybody else. The fact of the matter is, it's not about what the data actually show. It is and it is not about the science, even at the end of the day. It is about what people want to do with it, and it is about advocating specific policies. That is the real problem. And then, of course, there's people who just think it's always about taxes, even though at the end of the day, come on, let's admit it, Jeff Bezos doesn't deserve his money. It all belongs to me. I should have it, every last penny. Anyways, very last note before we end tonight. I was very distraught to find that this was actually more common than I really wanted it to be. But eco-fascists were occasionally around on the threads about climate change, and they were very much advocating for truly deplorable positions regarding the global poor, regarding immigration, all on the basis that they believe that this had something to do with the environment. This is a very worrying trend that is on the rise. In the past few years, there have been at least 2 terror attacks in Christchurch and El Paso, where the terrorists included as part of their motivation, yes, it was only part, but as an explicit part of their motivation, eco-fascism, a concern for the environment that drove them to their activities. And I saw multiple people in these threads trolling on the basis that certain parts of the population on the globe were undesirable and had to be gotten rid of. It was incredibly disgusting. It was extremely disturbing, and it is a rising trend globally. And that is why I can't simply say, we're just going to talk about the fun trolls, because this is becoming a worse problem. And because why am I ending with this that is so heavy when I was kind of having fun for a moment with my speed round? Well, the fact of the matter is, the entire reason I take this so seriously, the entire reason I got into caring about climate change is because I really believe that this is going to harm people. And I want to stop harm to people. I really want the takeaway from this talk, despite all the fun, despite poking fun at people, despite, having jokes, despite having a laugh, I really want people to walk away from this thinking that climate change is worth caring about, and that we all should be trying to take care of each other. That is the ultimate reason that this is actually serious, no matter how silly it seems. We need to take care of each other. Thank you.
Thank you very much, Trev. That was fantastic. We haven't had that many questions in through the box underneath the YouTube, but if you get them in quick, we might have time to get a few to Trev. We have one from Sean. Do you think better science literacy might help, or is it a failure of the media in explaining things and allowing debate?
This is going to get a little bit anecdotal. I think it's a little bit of everything, because I've had personal experiences with a wide range of people of various levels of scientific literacy, and various age groups and demographics, and susceptibility to trolls on social media. It's easy for us as skeptics to be like, oh, you shouldn't believe things you see on social media. But there's people who just in their day-to-day lives, they're not, they don't have time for it. They never got interested in it. They're not engaging with science all that much for whatever reason. That's fine. That's totally fine. They shouldn't, be lied to because of that. And when they're living their lives, what are they going to see? They are going to see that fake debate, both in the comment sections of their social media feeds as they're scrolling through, but also in the media, like you said. And when you put those two together, that sort of adds up in the backs of people's minds. So scientific literacy would certainly help, because that really does genuinely help inoculate you against certain things. There was one person that I was interacting with who fell for a lot of trolly things, largely through scientific literacy. And as I just politely said, oh, hey, the whole thing about volcanoes emitting CO2, that's easily proved wrong. She was like, oh, wow, I simply never heard of that. I'm now suddenly really suspicious of the groups of people that said that and the other things they've been saying about climate. And it sort of spread because now they have a little more awareness of where real knowledge comes from. But it's really not that simple either, because just the way the media frames it, the way trolls inundate social media to create this false impression, and even the way scientists, like, it's great that we have blogs and more of us are going out giving talks and things like that. There's still an ivory tower effect, and there's still a lot of problems in how we express our research. A lot of scientists offload a lot of the work to the PR arms of their universities, which do the best they can sometimes, and sometimes they do terribly, and that filters out into the newspapers, and it needs to be addressed on all levels, I think, from the scientist all the way down to the individual, and from social media organizations and newspapers. Every aspect needs to get on board with dealing with this.
We got a fun question from Vanessa Smith. She wants to know, is that a turtleneck? It's awesome.
It's actually not. It's
it's a fleece. You're not rocking the Steve Jobs then?
Oh, Lord, no.
And we have a question from Luna Canic. They want to know what your favorite argument is that you encounter.
Oh, I've been thinking about this so much, and I don't know. I have least favorite arguments. I mean, my least favorite arguments are I think CO2 is plant food is the one that really gets me personally, because my own research for the past several years has been on changes in light response of marine photosynthetic organisms, so plant-like organisms in the oceans. And photosynthesis is really complicated. And so reducing it just to, just give them more CO2, they'll be fine, is like, oh man, that's not how that works. For some plants, yes. For a lot of plants, no. And that's not even considering changes in temperature and rainfall. And it feels like such a kindergarten argument too. It's just sort of like, have you never overwatered your plants before in your life? Like, seriously, just stop and think about why you got so confident that you could reduce something so complicated to something so pithy. And that really gets under my skin. But at the same time, it's also the one that I'm most equipped to deal with as a scientist myself. So at the same time, it's also the one I engage with the most. So you could say it's my favorite.
Someone has asked, is there an argument that's caused you to think twice?
There's a few. I'm not sure I would phrase it as think twice per se. So for example, one of the more common ones is that the temperature data are wrong because they are taken on the ground and only satellites are accurate. It's very, very difficult actually to unpack why this is wrong, because it's profoundly complicated, because the instrumentation on the ground is definitely riddled with issues. You do have to make sure that you've got a broad coverage of the planet. You have to go out to sea. You also have to have things on land. You have to have them rural. You have to have them in cities. You have to have them at different altitudes. You have to make sure the instruments are calibrated the same. Instruments get moved a lot, and there's so many of them. And so it sounds like that's going to be full of errors, right? And so it sounds very simple, like, oh, well, the satellite just measures the spectrum of heat radiation, so that should be super easy. The problem is that a satellite is getting the entire altitude of emissions. And so you actually have to take the data from the satellite and you have to construct a scheme to give weight to different bands of radiation based on where you think in the atmosphere they're coming from, which means you have to calibrate that based on other instruments from the ground and from weather balloons and stuff. And so the result is that satellites have very large error bars. And so even though satellite measurements tend to show, quote unquote, less warming, they do show warming, by the way. I know a lot of people will say they show no warming. No, satellites show warming, but they do show, quote unquote, less. But the error bars are huge because it's really difficult to piece out what part of the atmosphere you're looking at. But it's really difficult to wrap your head around that. So when people have tried to point out the specifics of that, that has certainly given me something to like really grapple with, and that I've had to spend considerable amounts of time on before I could feel remotely confident talking about it. And I'm still not that confident. I would still defer people to go read stuff from remote sensing scientists. But yeah, that was a tricky one.
One last question before we wrap up. It might take us a little bit over time, but it doesn't matter. Elgman, have you encountered anyone who reuses troll talking points and behaviors in an earnest way, i.e. without trolling themselves?
That's really tough. I didn't have too much time to talk about it, but it's genuinely difficult to tell sometimes whether somebody is trolling you or whether they think they're making a real argument. And again, part of it comes back to sometimes people get a little confident in their conclusion, and then they'll start parroting something they heard on a fake news website somewhere. That person I showed with the wobble, like, I'm not entirely sure. Like, that person is very closely associated with another account, and one of them is fake because I caught one of them using the other account, and I don't know which one's the real one. But for a long time, that person really had me going that they truly believed that they were picking up on this. This person kept saying, like, look, I'm not a scientist, but I worked really closely with a scientist. Like, I was an intern somewhere doing non-scientific work, but for a scientist. And I picked up, I don't fully understand these arguments, but I know it's something like this. I was like, that almost had me going, because it seemed sort of like a mix of earnestness and just ignorance happens. We're all ignorant of some stuff. Once that person, like, spilled the beans by using the other person's account, I was like, oh, okay, this is a scam to you. But yeah, there are certainly a lot of accounts where I'm just like, I just don't know. And I didn't show any of them tonight, but there are certainly a lot of them.
I guess it's like with alt-med, which is like what I've investigated, people kind of, get so drawn in, and you can't tell where the charlatans start and the true believers end.
Yeah.
Well, thank you very much for stepping in tonight. You've been amazing and wonderful. And would you like to give out your Twitter handle so people can give you congratulations on your doctorate being awarded tomorrow?
Yeah, well, let's see if that actually happens. So you might have seen it on my title slide already. I'm at The Logic Man. I have weird feelings about that handle as well. maybe one day I'll change it, but that's where I am right now.
Okay, well, thank you very much, and we'll catch you next week. Follow us on Twitter and Facebook to find out what we're talking about. We're looking into getting a talk on incels, which obviously is very timely, but we'll let you know. So thank you very much, and we'll see you next week.